In this connection, it is interesting to notice that even today engineers are astonished at the performance of a constant current machine. Just as, some years ago, they used to consider it an extraordinary performance if a machine was capable of maintaining a constant potential difference between the terminals. Yet one result is just as easily secured as the other. It must only be remembered that in an inductive apparatus of any kind, if constant potential is required, the inductive relation between the primary or exciting and secondary or armature circuit must be the closest possible, whereas, in an apparatus for constant current, just the opposite is required. Furthermore, the opposition to the current's flow in the induced circuit must be as small as possible in the former and as great as possible in the latter case. But opposition to a current's flow may be caused in more than one way. It may be caused by ohmic resistance of self-induction. One may make the induced circuit of a dynamo machine or transformer of such high resistance that, when operating devices of considerably smaller resistance within very wide limits, a nearly constant current is maintained. But such high resistance involves a great loss in power. Hence it is not practicable. Not so self-induction. Self-induction does not necessarily mean loss of power. The moral is, use self-induction instead of resistance. There is, however, a circumstance which favors the adoption of this plan. And this is, that a very high self-induction may be obtained cheaply by surrounding a comparatively small length of wire more or less completely with iron. And, furthermore, the effect may be exalted at will by causing a rapid undulation of the current. To sum up, the requirements for constant current are weak magnetic connection between the induced and inducing circuits, greatest possible self-induction with the least resistance, greatest practicable rate of change of the current. Constant potential, on the other hand, requires closest magnetic connection between the circuits, steady induced current, and, if possible, no reaction.